arithmetic and geometric series. We're going to look at a couple of examples. Here's the first one, exercise 61, page 120. Someone's salary is increasing by a fixed amount each year. And if that's the case, that's an example of an arithmetic progression. It's going up by a fixed amount. So the first year he gets 16,000, the next year he gets 16,480, the next year he gets 16,960, and so on. Okay, an example of an arithmetic progression. To generalize this, if we want to find out about these things, then we generalize. And so, to generalize, we have this A, and then A plus D, and then A plus 2D, and then A plus 3D, and so on, as our terms. And if we wanted to add them together, then we'd have a series. So A plus, plus, plus. If we put a bracket around those, you can see the terms. Where A is the first term, and D is the difference. This is the first term. Sorry, it's not quite synchronized, is it? A is the first term. The first term there, second term, third term, fourth term, and so on. And so what we do is we say n for the term. So the n represents the term. N equals 1, n equals 2, n equals 3, n equals 4. And I'll define what A and D are underneath, but I just wanted to have them together. If we look at this, we can see that there's a pattern starting to emerge. To get the third term, this one here, I take the first term and add 2 lots of D. To get the fourth term, I start with the first term and add 3 lots of D, and so on. So for the nth term, which is what we generally write down, for the nth term, what would be an expression for the nth term? A plus, not ND, it's 1 less, isn't it? So n minus 1D, okay? And so we end up with an expression for the nth term, which is A plus n minus 1, I've run out of room here, D. And so that gives us an expression for the nth term. So if A is the first term, if D is the common difference, as it's called, then the nth term equals A plus n minus 1D. So that's the first important little result, because that means I can find any term in this expression, the nth term. So I talk about first, second, third, fourth, and so on, and then we try and generalize. So we talk about what's called the nth term, which could be anything. So the nth term is A plus n minus 1D. So if I want to find out what the 9th term is, then n is 9. So therefore, in our example, if we look back at our example, we're after what's his salary in the 9th year, here. so that's the nth term. So what's his salary in the 9th year? We just use that little formula. So therefore, for our example, the 9th year, n is 9. And the 9th term equals a plus 9 minus 1d. What is A in our example? 16,000, right. So this equals 16,000, which is his commencing salary, plus 9 minus 1 is 8, times D, which is the increment, 480. And that sort of makes sense, doesn't it? Because you're going around one lot of 480, then another lot, and another lot, so 2 times it, 3 times it, and so on, which is 840 pounds yearly. So we can find out any term in an arithmetic progression using that little formula here, this little formula. We can find any term. So now let's think about in this example, what's the total he'll receive in these first 12 years. So I now need to add them up as I'm going along. And in the textbook, it goes through the algebraic steps about how this formula is arrived at, but I want to just, really that's not important for us. So let's just present the formula to find the sum of an arithmetic progression. Let's see if I can remember it. Yes, that's right. So for an arithmetic series, the sum, as far as the nth term, so in other words, we always generalize here, the sum as far as the nth term is given by S for the sum, as far as the nth term, so n subscript n equals n over 2 brackets 2a plus n minus 1d. And that is the other formula that it's important that we can use, where again a is the first term, okay, and n is the position you are, the number of terms, and d is the common difference. So in our example, we want the sum as far as the 12th year, so when n equals 12. So therefore, for our example, the sum as far as the 12th term, and that's how you show it, sum subscript 12 equals 12 over 2 brackets 2 times 16,000 plus n minus 1, 12 minus 1 times d, which is 480. Which is something that the firm might be interested in calculating, because then they know how much money they're going to have to cough up for this guy over this 12-year period. So once we've got these formulae, and there they are put together, we can manipulate them like any algebraic expression. So if I know what the nth term is, for example, if I'm given the value for the nth term, and I know what the first term is, for example, I could find out what the common difference was. What is this increment that's being given? If I'm given the sum, say I have a budget of £100,000 to spend on something, and it's going to be spread out in some sort of arithmetic progression because I'm giving some sort of increment or a bonus or something, I can say, okay, if I'm going to give this total amount of money over, say, 20 years or something like that, how much can I afford to give as a start wage or as a bonus? And you can work out things, and that's the sort of thing I'm going to be asking you to do in the assignment. So in other words, you can rearrange the formula and find other terms apart from the sum or the nth term. For example, so let's look at this example here. 5,000 to be spent over 15 items, each one to have a value of £25 more than the previous one. What's the price of the first item and the 15th item free? So what do we do? Suggestions apart from Ed? Okay, so at the start point, write down what we know. We know D is £25. No, you're right, we don't know A. What else do we know though? We know the sum, right? We know the sum as far as what? Right, because there's 15 items, is £5,000. So by definition, we know N, don't we, is 15. It's the number of items we've got, so therefore, yeah. Okay, where do we go from there then? Which formula is going to be useful? So right, this formula is going to be the useful one. So therefore, 5,000 equals 15 over 2 brackets 2a plus 15 minus 1d, which is 25. Now we've got a little equation to solve. So work out what you can and then simplify it as far as you can and then calculate A. Let's see. What would we do? First thing, suggestion. Go on then, Ben. Yep. 350. Where did you get the 350? 5 to 25, right, okay. Okay, yep. Yep. So 5,000 equals 7.5. Yep. Now what do you do? Okay. Yeah. I'm going to times the 7.5 by 350. What else have I got to do with 7.5? Right, so, yep, so I get, what's 2 lots of 7.5? 15. 7.5 times 350 is? Sorry? 2625? Yeah, well, yeah, that doesn't matter, Richard. There's more than one way to do these things, that's fine. No, at this stage I do something different, Ben. Look at it again. 15a plus 2,625 equals that. What would you do now to try and get a on its own? Not divide, but subtract. Subtract 2,650 from both sides. Sorry, 2,625. So subtract that from 5,000. What do you get? Oh, is that what you said? I thought you said divide, sorry. And then you said divide that by 15. Yeah, you're right then, Ben. I didn't hear you say the subtraction bit. So therefore then A equals 2375 divided by 15, which is? Sorry, So, what did you do, Richard? Yep. Here. Yep. Yeah. 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 You see that, Ben? At this point, the suggestion is that at this point, instead of multiplying out the bracket, perfectly valid, is to divide both sides by 7.5, and that way you get 5,000 divided by 7.5 equals 2a plus 350, and you get the same answer. So it's whichever you see, whichever way you see. Yep, that's a, and a is the first term, isn't it? So therefore the first term a is, yeah, £158.33. So that's the price of the first item. Well, to get the nth term, that's right, remember the nth term now, so therefore now we want the last term, don't we? So the 12th term equals, using the formula, a plus n minus 1d, isn't it? So it's a plus n minus 1d, which is going to be a, which we now know is £158.33, plus 11 times whatever the difference is. What was it? £25, yeah. And then whatever that is. Two seven five three seven five 5 3 something. What is it? 433.33. So in this example, the first item is going to cost £158. The last item is going to cost £433, and if we added them all together, it would all come to £5,000. So now let's look at another example. R2 firm finds that their net return is decreasing by 10% per annum. So it's a percentage decrease. So that means it's not a fixed amount, because as it decreased, that percentage gets less, doesn't it? So another example would be something like compound interest, which is something that's often calculated in the bank. That's an example of something called a geometric progression, where it goes up, not by a fixed amount, but by a fixed ratio. So that's a geometric progression. So let me show you generally what this means, and then we'll look back at this example again and try and solve it. So this is an example of a geometric progression. Again, we start off with the first term, a, but then we multiply to get the next term. We multiply by a common ratio, by a constant, by a number, AR. And the next term will be AR multiplied by that again, so AR squared. And the third term, the fourth term rather, will be AR to the power 4, and so on. And again, if we're adding them together, that would give us our geometric series. Yeah, so if we went to the nth, AR to the n, I'll give myself a bit of room to do that this time. We can predict, so this is the, might not be an n, might it? We might decide. So we get to the first term. N equals 1, n equals 2, n equals 3, n equals 4, Why did I go from 2 to 4? Anybody tell me? That should be a 3, shouldn't it? Nobody spotted that deliberate mistake? AR squared, AR cubed. I missed one out for some reason. And so can you see the pattern now? It's AR to the n minus 1, like it was before, isn't it, if I want the nth term, okay? Because we can see that n is 2 here, so we've got AR. When n is 3, then we're squaring it. When n is 4, we're cubing it. So the nth term must be AR to the n minus 1. And that's the nth term. So what's the expression for the nth term in a geometric progression? It's the first term, a, times what's called the common ratio to the power n minus 1. So a is the first term. And r is what's called the common ratio. You can think of it as a multiple, what we multiply it by, the common multiple. For example, let's have a look at one or two. E.g., we start off with 14 and we multiply that by 1.1. What do we get? Calculator, please. So 14 plus 1.4 is 15.4, isn't it? Is that right, Richard? To get the next one, we multiply that by 1.1. I'm making it up at the moment. So times this one by 1.1, what do we get? 15.4 times 1.1? 16.94. Multiply that by 1.1. 18.63, and so on. Okay? Let's look at this one in a bit more detail, this example. First thing, a equals 14. For this particular series, n equals 1, 2, 3, 4, and so on. So that's the fourth term, 18.63. If I hadn't told you that the common ratio is 1.1, what could we do to work out what it is? No. Right, divide 15.4 by 14. What do we get? Right, divide 16.94 by 15.4. Divide 18.63 by 16.94. 1.1. In other words, that's where the name common ratio comes from. If I find the ratio of any term and the one before it, then that gives me my multiple, the common ratio. So R equals 1.1, which is any term divided by the one before it. Another way to think about it is that's what I've got it, that's what I now multiply a given term by to get the next one. So if I want to know what the fifth term is, I'd multiply 18.63 by 1.1. Now, if I think of this as money, if this was money, £14, £15.40, £16.94, and so on, £18.63, this is increasing by a fixed amount. Sorry, by a fixed ratio each time it's going up. Okay. If I want to find a 10% increase, if something increases by 10%, something's cost £14 and increases in value by 10%, what will it be worth after if I do that? Right, because 10% is the 100% plus the 10% I multiplied by 1.1, don't I? A 10% increase is 110% of what we started off with. So it's the 100% plus the 10%, which is 110%. And how do I find 110% of something? I multiply by the percentage and divide by 100, don't I? So this is times by 1.1. So a common ratio of 1.1 means an increase of 10%. So what would the common ratio be for an increase of 20%? And so on. Okay. What about a decrease? If I decrease it by 10%, 0.9, okay, it would be the 100% minus 10%, leaving 90%. So a common ratio of 0.9 corresponds to a 10% decrease. So something's increasing by 10% multiplied by 1.1 is something's decreasing by 10% multiplied by 0.9, and so on, because of our understanding of percentages. So looking back at the example that we had here, what's involved here? A hire tool firm finds that their net return from hiring tools is decreasing by 10% per annum. So it's a geometric progression because it's decreasing by a fixed ratio, 10%, it's going down. So what would R be? 0.9, yep. If their net gain on a certain tool this year, so at time 0, at the start of this progression, if you like, it's starting at £400. So that's what that means, Ben. This year, their net gain on the tool is £400. Next year, it will be £400 less 10%. So as time progresses, this particular tool is going to decrease in value by 10% per annum. Find the possible total of all future profits from this tool, assuming the tool lasts forever. So let's have a look at this. So we can now start to work out what the progression is. Write down the first few steps for this progression. So call this problem. So for our example, A equals £400, was it? R is 0.9, which corresponds to a 10% decrease. So therefore we've got n equals 1. Two, 3, 4. Let's write down the first 4 years. So year 1. Yeah. So actually, yeah, that's right. Inflation and so on. Yeah. So n equals 1. Our first year, £400. Our second year, is it 360? Yeah, it will be, won't it? take off 36 of that is 328. Is that right? 10% of 36 is 36. 322. 324 even. And so on. Okay, what's the next term? Times that by 0.9. 291.8. And so on. Okay. What will be the value of this item after 20 years? No, there is a formula, luckily, that we're going to come to. How much would it be worth or what will they be getting from this thing if it's decreasing by 10% after 20 years? Yeah. What's the value of the car after 20 years if it's depreciating at 20% or 10%? Yeah, exactly. So which formula? What's the formula? Nth term equals AR to the n minus 1. Okay, so after 20 years, £54. After 30 years, it'll be less than that, won't it? It's going to get smaller and smaller and smaller. But approaches 0. Yeah, that's right. So there is a point at which it comes to nothing. So if you think about adding this series up, first term plus the second term, that's this, plus the third term, plus the fourth term, and so on, there is a point at which it becomes 0. It's getting smaller and smaller and smaller. So in theory, we can find the sum as far as what's called infinity. In other words, nothing yet. Because it's getting smaller and smaller by 10%. And if you think about that, actually, as this value gets smaller and smaller, the percentage decrease gets smaller and smaller. So it approaches, but in theory, never actually equals 0. It just gets smaller and smaller and smaller. So we find something called the sum to infinity, which you can do for progressions that get smaller. So when the common ratio, and in this case the common ratio is 0.9, is less than 1, that means, doesn't it, that it's decreasing. Yeah. So you can find the sum as far as infinity. If r is greater than 1, it's increasing. So we can't find the sum as far as infinity because that infinity would be an infinite value, wouldn't it? Because it's getting bigger and bigger and bigger. So for series that are getting smaller, i.e. r equals less than 1, we can find the sum as far as infinity. And again, the textbook takes you through how to find how it's arrived at, but the formula turns out to be very straightforward. So for a series where r is less than 1, we can find the sum of all possible terms, i.e. sum to infinity, a over 1 minus r. So for our example, the sum as far as infinity, in other words, all possible money that we can get from this hire tool, just turns out to be a, which is £400, over 1 minus 0.9. And what does that turn out to be? Yeah, which is? No? 4,000, yeah. So what's the total he's going to make out of this thing? £4,000. So for this question, it actually turns out to be trivial to work out the total possible future profits for this tool. It turns out to be £4,000, just sum equals a over 1 minus r. But what you need to realise from that is that a, the first term, is £400, but more importantly, that because it's decreasing by 10%, r equals 0.9. Okay, and then you can do it.